Hey there, have you ever really thought about how we know how big something is? Or how we can even talk about a car moving down the street? Well, today we're going to dive into the super cool world of measurement and motion. We're going to find out why your hand might not be the best ruler and check out all the different ways things move around us every single day. But first, let's start with a little puzzle for you. Imagine you've got this table in front of you and you absolutely need to know how long it is. The catch, you don't have a ruler. No measuring tape, nothing. So, how would you do it? Just think about that for a second because we're definitely coming back to it. Okay, so we all know this guy, right? The good old ruler. It's awesome for measuring things that are nice and flat and straight, like the edge of your notebook or a line you've drawn. But what happens when things get a little curvy?
Well, for that, you need something different. If you're trying to measure something that bends, like maybe your waist for a cool costume, you need something flexible. And that's where a tailor's measuring tape is perfect. See? It can bend and wrap around things, no problem.
And then you've got this, a meter rod. A shopkeeper might use one of these to measure out fabric. It's long, it's straight, and, this is important, it won't stretch. All of this tells us something really key. You gotta use the right tool for the job to get the right measurement. All this talk about tools actually leads us right into a story about a group of friends and a little measurement puzzle they tried to solve. So let's meet our friends. This is Deepa and our pals. And just like us, they were pretty curious. They had this big question on their minds. What really is the best way to measure something and get it right every time? So they came up with a fun idea, kind of like our puzzle from the beginning. They decided they'd try to measure a table without a ruler. Instead, they were going to use their hands. They used what's called a hand span. That's the distance you get when you stretch your hand out from the tip of your thumb all the way to the tip of your pinky. They all got to work measuring the exact same table, but something really weird happened. They ran into a pretty big problem. Just look at their results here. Anish got a little more than 13 hand spans, Padma got exactly 13, Tasneem got a bit less than 13, and Hardeep measured a full 14. Wait a minute. How is that possible? They all measured the exact same table, but everybody got a different answer. So what do you think is going on here? How can one table seem to have so many different lengths? Take a second and see if you can crack the case. Did you figure it out? It's actually super simple. Everyone's hands are different sizes. Anisha's hand span is different from Padma's, and hers is different from Hardeep's. This whole puzzle shows us something really, really important. To measure things the right way, we need a way to measure that is the exact same for everybody, everywhere. And that handspan problem leads us straight to a brilliant solution. A system of measurement that works for every single person, no matter where they are in the world. It's like a universal ruler. And this is called a standard unit. Think of it as a measurement that never, ever changes. It's the same for you, for me, for an astronaut in space. The system that almost the entire world agrees to use is called the SI, which stands for the International System of Units. It's like a secret code for measurement that everybody understands. Let's see how it works. For really long distances, like from your city to the next one, we use kilometers. And 1 kilometer is always equal to exactly 1,000 meters. No more, no less. Okay, now let's zoom in a bit. For things we see every day, like say the height of a door, we use meters. And every single meter is made up of 100 smaller parts, all the exact same size, called centimeters. And if we zoom in even more, one of those centimeters is made of 10 even tinier little parts called millimeters. These are perfect for measuring super small things, like how thick a coin is. See how it all connects? From huge kilometers down to tiny millimeters, it all fits together perfectly. Okay, so we've got our universal ruler, our standard units. Now we can measure the distance between things. But that brings up a new question. To measure a distance, you always need a starting point, right? So how do we even describe where something is? To do that, we need something called a reference point. The easiest way to think about it is like the "you are here" dot you see on a map. It's a spot that doesn't move, and we use it as our starting line to describe where everything else is. And this picture shows it perfectly. Let's say our reference point, our starting spot, is Deepa's house. From there, the school looks pretty close by. But what if we change our reference point to the bus stand? Well, from the bus stand, the school seems much farther away.
The school didn't move an inch, but our starting point did, and that changed everything.
All right, so we know how to measure distance, and we know how to use a reference point to say where something is. Now, for the last piece of our puzzle, what happens when something changes its location? In other words, how do things, well, move? The simplest kind of movement is called linear motion. Now, that's just a fancy way of saying moving in a straight line. You see it all the time. When an orange lets go of a tree branch, it falls straight down. That's linear motion. Simple as that. Next up, we have circular motion, and I bet you've seen this one before. It's when something moves in a perfect circle. Think about the horses on a merry-go-round at a fair. They just go round and round and round, always following that same circular path. And our last one is a fun one. It's called oscillatory motion. This is any kind of movement that repeats by going back and forth, back and forth. You know, like when you're on a swing at the park, or if you've ever seen the pendulum on a big grandfather clock, that steady, wobbly movement is oscillatory motion. So there you have it. Straight lines, perfect circles, and back and forth wiggles. Motion is literally happening everywhere, all the time. Now that you know the real names for these movements, here's a little challenge for you. As you go about your day, see how many examples of linear, circular, and oscillatory motion you can find. I promise you'll be surprised at just how much moving is going on.